Well, hi there, Math 100 Online. In this video, I will address the challenging problems that you stated in the discussion board a couple of weeks ago. So, let's begin. The first problem I'm going to go over is on page 179 of your textbook, and it's number 27. What you see is a trinomial times a trinomial, and you're used to multiplying binomials times binomials. Binomials are two terms times two terms, right? Binomials times binomial. We call that foiling, first, outer, inner, last. And foiling is essentially distributing. So as long as you multiply everything in one parenthesis times everything in the other parenthesis, then you should come out with the right answer. So our goal is to multiply everything over here times everything over here. For example, x squared times everything over here. Then we'll turn around and multiply negative 2x times everything over here. And then we'll turn around and multiply negative 5 times everything over here. So let's get started. First, let's multiply x squared times everything in this parenthesis. And what I'm going to use is sort of like a stack method where I am stacking like terms. Okay, so let's first multiply x squared times x squared. That's x to the 4, right? X squared times 3x is 3x cubed. X squared times negative 7 is negative 7x squared. Always go back and check your answer, because if that first line is wrong, everything else will be automatically wrong. Alright, so x squared times 3x, x squared times negative 7. Okay, I think we're good with that. And change colors. Negative 2x now times x squared. So now we're going to multiply negative 2x times everything. Negative 2x times x squared is negative 2x cubed. So I'm going to put negative 2x cubed under 3x cubed because they are similar. They are like terms. And that way I can keep up with my like terms. Negative 2x times 3x. Negative 2x times 3x is negative 6x squared. Again, stacking that under the x squared term in the first line. Negative 2x times a negative 7 is a positive this time. Positive 14x. Alright. So we're done with negative 2x. Let's go on to negative 5. Negative 5 times x squared is negative 5x squared. So where should I put negative 5x squared? I will put it here, negative 5x squared. Negative 5 times 3x is negative 15x. Negative 5 times negative 7 is positive 35. So we get to add these together, and because we stacked it, it makes it easier on us to find out what the final answer is. So I'm going to go ahead and drop the x to the 4. 3x cubed minus 2x cubed would be a positive 1x cubed. Then we have negative 7 minus 6, negative 13 minus 5, negative 18x squared, 14x minus 15x, negative 1x, we'll write negative x, and we're going to drop our positive 35. So this is your answer for that first problem. Next, we have a problem that was taken from page 166 of the textbook. If you want to refer to your text or your ebook, page 166, number 120. So this problem looks pretty lengthy. Probably don't want to have to multiply all of this out. This is x plus 2 squared, so you would have to multiply x plus 2 times x plus 2. By the way, you have to FOIL that out. There's no shortcut method of doing this. You have to write it out twice and FOIL. But I'm going to use a method called a substitution method, because it looks like a trinomial if you look at it. It's something squared minus that same thing plus a constant. So it looks like a trinomial if you kind of compare trinomials to this. So what I'm going to do is I'm just going to substitute something right quick. Substitute, we're going to use u equals x plus 2. So I'm going to change this problem to, write this in red, 15. Now if u equals x plus 2, then it's going to be u squared minus 13, right? U again plus 2. So I'm going to factor this first. Right? We're going to factor this, and then we'll turn around and plug in x plus 2 in the end. So how do you factor this? This is a trinomial. We'll use the AC method. We'll multiply a times c. A times c, 15 times 2 is 30. We'll find factors of 30 that add up to negative 13. So 1 and 30, 2 and 15, 3 and 10, 5 and 6, and so forth. Which factors will work so that you will have a positive 30 when you multiply the factors, and you will have a negative 13 when you add them. It looks like negative 3 and negative 10 will work. Right? Negative 3 times negative 10 is positive 30, but if you add it, you get the negative 13 that you need. So that's 15u squared. Then I'm going to expand the middle term to 2 terms so that we can factor by grouping. So I'm going to put in here negative 3u minus 10u plus 2. And make sure this works. This right here has to be equivalent to this. Alright, and it is. We're going to factor by grouping now. I can pull out a 3u, then that's 5u minus 1, and over here I can pull out a negative 2, and I get the same thing. That's how you know you're on the right track, when you get the same thing here. If not, you didn't do something correctly. So the final answer for a moment is 5u minus 1 times 3u minus 2. However, what does u equal to? U equals to this, right? So we're going to make our final substitution. Okay, so final substitution, we know that we have 5, but we know that u is really x plus 2, right? Minus 1, and then we have 3u, which is x plus 2 minus 2. And since we use parentheses already, really we need to use brackets if you want to be use proper notation here, since there are already a parenthesis inside. Now we can just simplify this, and that would be your final answer. So we'll distribute this, and that'll be it. So that's 5x plus 10 minus 1, and then 3x plus 6 minus 2. So the final answer is 5x plus 9, since 10 minus 1 is 9, and 3x plus 4, because 6 minus 2 is 4. That's your final answer. Next, we have a problem that looks like this, and this is something that you should have seen in chapter 3, because this is actually a difference of squares, and the reason why you should recognize it as a difference of squares is because treat this as one term. This is one term. You have a minus sign in the middle, and you can find the square root of both of these terms because both of these are perfect squares. What is the square root of x plus 2 squared? The square root of x plus 2 squared is just x plus 2, because, let me write this over here, x plus 2 times x plus 2 equals x plus 2 squared. Just like if I ask you what is the square root of 9, what's the square root of 9? You would say 3, because 3 times 3 equals 9, right? So yes, you can find the square root of these things, therefore they are perfect squares. So here's how you treat perfect squares. You write, put these two parentheses. What's the square root of x plus 2 squared again? Just x plus 2. Make sure you put it inside parentheses because these are binomials, and you need to preserve that parenthesis for now. What is the square root of x plus 9 squared? It's x plus 9, so write that there. Write it twice here. Now, make sure you keep that parenthesis. What are the signs for the difference of squares pattern? It's always a plus and a minus. Alright? Usually you can stop there. However, you can't stop here in this particular problem because there are like terms inside of both parentheses. Therefore, you can simplify this even further. Alright? So you have x plus 2 plus x plus 9 here. So I'm dropping the parentheses, and it did not affect the sign because there's a plus sign here. However, in this parenthesis we have x plus 2. Signs will be affected because there is a negative, a minus sign here, and you have to distribute the negative 1. So because of that, it becomes negative x minus 9. Alright? We have like terms x plus x, which is 2x, plus 2 plus 9 is 11. Next you have x minus x, which cancels, and you're only left with a negative 7. So your answer is 2x plus 11 times negative 7, or which I like putting this in the front. So negative 7 times 2x plus 11. Both are correct. I just prefer negative 7 times 2x plus 11. And we're factoring again, of course. As you can see, the very first step of factoring is GCF. However, we do not have a GCF because there is nothing in common with all 4 terms. And when you see that there are 4 terms, you should recognize that maybe you could group 2 terms together, and we can factor by grouping. So I will show you this problem 2 ways. The first way is I'm just going to group these 2 together, and what we can do on the second time around is we can rearrange terms, but it's really not necessary to rearrange terms, and let me show you why. For example, there is something in common with these first 2 terms. It is y. So we can pull that y out of the first 2 terms, and we're left with 2x plus 3. what we want to happen on the right over here is to have 2x plus 3, and we already have 2x plus 3. But we have to pull out something here anyway. And in order for it to be legal, the only thing we could pull out is to say 1 right here, because 1 times 2x plus 3 will give you back this part, right? If you can't put something here and it doesn't give you back the same thing as the previous line. So that's what we wanted. We wanted to have the same thing in the parentheses here, and because we do, that is our new GCF. So we pull out that common binomial factor, which is 2x plus 3. And when we pull out that 2x plus 3 from both terms, what's left over? Y plus 1. Alright, so this is still the original problem, but let's say you wanted to rearrange terms and you wanted to group 2xy with 2x, and you wanted to group 3y with 3. That's perfectly fine. Let's continue to factor by grouping, and what you can do is pull out a 2x here, and you're left with y plus 1. Always check this, always distribute, and make sure you get back the same thing as what's in the previous line. Next, you have 3y plus 3. You can pull out a 3, right? So again, that's y plus 1. And that's what you want. You want the same thing to occur in those parentheses. That's how you know you're on the right track. So your final answer here would be y plus 1 times 2x plus 3. And if you compare the first way to this way, you'll notice that the answers are exactly the same. The factors are just in a different order. And multiplication is commutative, so order doesn't matter. You'll still get the same thing if you multiply this out. So that is all of your challenging math problems addressed.